everyone. This is part 2. As you remember, last Power Platform user group, I did do how to do simple linear regression in Power BI, a quick demo on that. So today I'm going to be doing the second part. It was a question actually that was asked at that meeting if we could do multiple linear regression in Power BI. So hopefully that person who asked the question is back because I have the answer for you. Again, so my name is Deanna Arciniega. I am an analytics consultant at Iteration Insights. I focus a lot on Power BI governance. I do teaching of the introductory course at Iteration Insights. I do a lot of how-to guides and blog dashboards like this. I also help clients rebuild reports and help them manage Power BI as an organization. So let's get started. So I created kind of a PBIX that is just for this demo, and I am going to have it posted in the blog as well after maybe sometime this week. This is going to have everything that I've talked to you about today, as well as links to any resources I've talked to you about today. And also, it will also have the data set we're using, so you can actually try the demo yourself in that PBIX file that you download. There is one already in the blog itself. However, this one just has the added things that we're going to be doing today in just stuff that I'm going to be talking about at the beginning. So you can do this too. We are going to be learning how to do the house price predict-o-matic. We're going to predict the price of a house based on the number of bedrooms it has, bathrooms, and also the square foot living of that house. And we're going to be doing that by using the statistics model of multiple linear regression within the Power BI by leveraging the R script function in Power BI. So I'm going to talk a little bit about what is analytical forecasting, what is multiple and linear regression, and then we're going to go into predicting the price of a house in Power BI. And just to show a quick demonstration of how it works and what you're going to be doing, this price predict-o-matic, if I choose, maybe I want a house with 3 bedrooms and 2 bathrooms, and I want maybe 60,000, close to 60,000 square foot living, then the predicted price of this is that house is going to be $1.77 million. Obviously, this is a fictional data set, but it is cool to see the power of Power BI and R and statistics all put together in this house price predict-o-matic. All right, so let's talk a little bit about predictive analytics, also called analytical forecasting. And it's the method of using modeling techniques to make predictions about the future outcomes and performance. And so it looks at all the data from the past and tries to predict what will happen in the future based on patterns that they see and anything that a pattern that might likely emerge again. So it allows organizations to prepare themselves, to adjust themselves in order to maybe they have to streamline their operations, maybe they saw some bottleneck in their operations, maybe the predictive analytics will show them how much they need to supply themselves of resources so that they will not run out of things when the time comes. So to make these predictions, organizations use things like machine learning, which is when machines learn from their mistakes and adjust themselves. Artificial intelligence, which is technology that simulates human behavior. We've got data mining, which is intelligently extracting information and transforming the information to a structure so that they can use it in the future. And then we have our modeling and statistics, which is where the multiple and linear regression falls into. So there is multiple models and statistics that you can use for forecasting. These regression models are just one of many. There's lots of things you need to do on the data to check to see if this model can be used on the data. And I'm going to talk a little bit about that in a second. Oh, and by the way, the resource I got for everything I'm talking about is from Investopedia. I will put that in the PBIX as well in case you wanted to go explore more of what is predictive analytics. We also have actually a blog at Iteration Insights that is on the 4 types of analytics, I believe, by Renata, our host of the user group. And one of the analytics is the predictive analytics, and it goes into what that is a little bit as well. So we can probably throw that in the chat for you at the end as well. Let's go into what linear and multiple regression is and what is the difference. So regression is determining patterns in large sets of data that have a linear relationship between the inputs. What do I mean by that? As you can see in this picture here, this picture is from my simple linear regression blog where I was trying to predict the salary of an employee based on how many years of experience they have worked at the company. So you can only perform linear regression or multiple linear regression on data sets that have a linear pattern. So as you can see in this graph, all the dots kind of hug the line. They are very close to the line, which shows a linear pattern. And for multiple linear regression, we want to do it based on multiple values. So in the case maybe of the simple linear regression, if I wanted to do it on multiple values, I could maybe try to predict salary based on years of experience. Years of experience, maybe like a performance factor, maybe different their education, maybe like how many certifications they have, their age, like there's a bunch of different factors that you can put to predict the price, and that is multiple linear regression. So it's predicting it for multiple variables instead of that one variable, which is the years of experience. So another thing I really wanted to mention is that you have to test your data for the 4 assumptions to see if you can use this model. This is very important. What do I mean by that? You cannot perform linear and multiple regression on just any model. It has to basically go through a checklist of 4 assumptions to make sure the model will represent valid information. You can do this on any data set and it will give you results. They just might not be very valid. They can't be used in real life or business. They won't be accurate. When it comes to all of this forecasting, we want to be as accurate as possible so that we don't waste our resources. So it's extremely important to test for these things on your data. Unfortunately, I have not figured out how to do all these tests in Power BI. There are ways to do this in R. A lot of statisticians use R to test the data before applying models to it. So things that you would test your data for is like the first thing I said, is there a linear relationship between both the dependent and independent variables? So that would be between the y and the variables that we want to see if what predicts the y. So for example, the linear regression one where we had one variable, so we had the salary and we are basing it on years of experience, we saw that there is a linear relationship between the two of them when we put it in a scatter plot. for the example that I've done in the multilinear regression blog that I'm going to do, it's going to be a data set on the housing that you saw at the beginning. We're going to be doing the Predictometric. And so with that one, you have to make sure that every value is linearly related to the price. So it's going to be a scatter plot of price versus bathrooms, a scatter plot of price versus bedrooms, and then price versus square feet. And you're going to check each one of those scatter plots to make sure that they each have a linear relationship. And then you can confirm whether the first of the 4 assumptions has been met. A couple of the other ones are there can be no major correlation between the values. So in multiple linear regression, in our example, between bedrooms, square foot living, and bathrooms, there could be no correlation between the 3 of them. So no relationship at all. So that would be like the second assumption that you would need to check for. There are different ways that you can check this in R. There are going to be resources I will put as well in the chat in a second here as well. They're going to be in the PBIX for you as well on really good articles that I found on how to do multiple linear regression in R, as well as checking for the 4 assumptions in R. So I'm hoping that you can use these resources to check your data and then apply the model that or the Power BI instructions that I've provided to your data once you have made sure that your data is met by the 4 assumptions. The last 2 would be the residuals. So it's to check that the residuals have a constant variance at each level of X. And I know this is like a bunch of stats talk right now, but basically it's how much is there a difference between the observed data point and the predicted data point. So for example, in this little graph here, the salary by years of experience, how much difference is there from the data point to the line here, or to whatever data point that lies on the line? And is this relatively consistent for every single data point? So you can do that with like a fitted values versus residuals plot in R. I've got some articles that can show you how to do that. And for the 4th one, the residuals just have to be normally distributed. So you can do this with a Q-plot in R, and it just means that the data is more near to the mean of the data and more frequent in occurrence than far from the mean. So it's making sure that there isn't any extreme outliers that will affect the overall price or what we are predicting. So one thing I did want to note is with this data set, it's quite small. And with a small data set, like for this demo, you usually don't meet the 4 assumptions. So the data set that I'm using does not meet those 4 assumptions. I did just choose it for the purpose of demonstration. And so it's not accurate in any way. However, it does help to see steps, I feel, when you see something a little bit smaller before you see it bigger. So I'm just going to throw a couple things in the chat right now, and then I will move on to maybe a couple cases. This article, Multiple Linear Regression by Neil A. Ack. I can't say his name right now. I'll try it again once I copy paste it. Akil Durim. He did a wonderful article on going through all the steps in R on how you would check your data to make sure that you can use this model. And then I have a couple more here that I'll throw for everyone. And it's just some more explanation on what I mean by 4 assumptions. There's one that's a little bit more heavier, and the other ones is just a quick and simple guide that will give you a quick description on each one of the 4 assumptions. So I'll just send that over and then we can continue. Okay, so just a couple of examples of what linear and multiple regression are. Regression can be used to predict consumer behavior. So, for example, for a store like Walmart, we can use regression to predict what products the people in the country that Walmart resides in will likely buy. So what they will do is they will check out all the transactions that have been happening at those stores, for example, in Germany, and analyze which products are selling the most at those stores in Germany. And they will use regression to predict how much product we need to buy to supply that store to make sure we are reaching the right consumers and not running out of the products that store needs. So this will lead to consumers making more purchases because the products that they need will be there more often and in more supply. So same thing like in a place like McDonald's, they will always, well, they plan to always have their staff, the proper amount of staff, a person at every station. They have targets maybe for every day, how much money they want to make, what do they want to market the most. Maybe they ask their drive-through person like, hey, maybe try to advertise ice cream today and we'll put on a target goal. But all those things can be predicted using regression if they have maybe linear regression if they have a linear relationship. And it will check to see from that store, from that McDonald's store in let's say this day last year, they will see how many people came to the store in the last 5 years on this day. How many people or how many batches of fries did we have to make that day? And then we'll take all that data, we'll assign a factor to each one of those things, and we will predict how much we need of the supply or how much customers we're going to expect that day so that we can plan for how much staff do we need to organize at the McDonald's. How many drive-through people do we need this day? Do we need only one person at drive-through? Can they handle it? Or is it going to be extremely busy like it was the last 5 years? So that is how we can use regression to predict consumer behavior, to elevate your organization, to prepare in advance for any changes, any seasonal or environmental changes that can be predicted. A lot of insurance companies use this. I know I have a few examples as well in the actual blog that are different as well on blood pressure and forecasting crop growth. So there's so many things you can use it, and I think that's why I fell in love with statistics. It's all about predicting the future with the knowledge that we have now and preparing. Awesome. So before we get started, let's go to that page. I'm just going to get my little pen here. So multiple linear regression uses the equation, this extremely daunting math equation. So y equals, I'm going to say the actual letters, and then I'm going to break it down. So b0 plus b1 x1 plus b2 x2 plus, and then it's ... It's basically just saying for however many coefficients that you want in your equation. So p and p just signify whatever the number that you will stop to. All right, so y is our predicted value in the multiple linear regression. And this is what we want to predict. So that is going to be our price. So I'm just going to write P for price equals. And our B0 is our intercept. So an intercept is the number that represents the mean value of the price when all of the coefficients, which we're going to look at in a sec, is equal to 0. So let's come back on B0 intercept because I think it will make more sense when we talk about the coefficients. So we have our B0. Again, this is the mean value when our coefficients, so our B1, B2, BP are 0. So the number, so it would be 0 times our bedrooms, 0 times our bathrooms, 0 times our square footage, and it would be the mean value of that. Perfect. So then we have our slope coefficients. So I think the best way to explain what slope coefficient is the power. It is how much power that value has to the price. How much does it affect the price? So, for example, if when you do the R script on this data set, it's going to calculate how much of a factor did all of those bedrooms in that data set have on the actual price that was stated. And it's going to put a number to that. How powerful is bedrooms to the value of the price of the house? How powerful is or how important it is. And that's going to be expressed in a value and a number, which we call a slope coefficient for each explanatory variable. And an explanatory variable here are the bedrooms, bathrooms, and the square footage. So what we're going to be doing is we have the price equals our intercept. The intercept is going to be calculated within that table of values within the R script that we're going to make. Then we have our slope coefficient. So that's going to be a number that's, again, going to be brought back by Power BI. So let's say 7.2, I'm just making up something, 7.828. So this is going to represent how powerful that number is to whatever explanatory variable this is. So I'm going to draw a little bed to signify bedroom. Okay, so this is 7.28 bedroom. So this means that bedrooms have a influence of 7.28 on the price. And that's how it's going to calculate the price in the end. So same thing with each slope coefficient and variable. It'll have a random number, 8, 2, oh, I don't know what that number was, my apologies. And then it would be like bathrooms. And then we would do the same thing for the square foot living. Perfect. So we're going to be doing this using the R script in the Power Query Editor in Power BI. We're going to be creating what if parameters after that so that we can show that. Those are like the slicers that you see in the beginning there. Let's go back to the agenda homepage. These slicers right here are the going to be our what if parameters. There's things that we can input so that we can put whatever we want to input and it'll show whatever we want to see. Oh, and then after that, we're going to create a card value. And if I have time, maybe I'll show you how I formatted it just a little bit. And then hopefully you can try it yourself with some fun data sets that you find over the internet. One thing I wanted to note with the R script, it will not work on your Power BI if you don't have R actually downloaded to your computer. So you have to have, it's going to be kind of connecting to that R engine in your computer in order to run that R script. So I will put not a download link, but a link to the website where you can download R, and it is free, by the way. So you would just need to have that on your computer in order for you to use our script and do this demo. Perfect. So first thing I want to do is show you the data set that I'm using. I thought I had it open. My apologies. It must have closed. But I am using a Kaggle data set. Kaggle has a lot of wonderful open data sets, really fun data sets. So I got it from the Kaggle site. I actually think I have it here. Okay. I will also have this link there for you as well. So this is where I found it. There's lots of data sets here in this website that you can use. There's like Netflix one. There's like Game of Thrones ones. Very cool. So this data set is actually a lot bigger than the demo in the blog, like in the steps in the instructions. So this is what it looks like originally. This is this is after I have saved it to my computer. It will download as a CSV file. I saved it as an Excel just for convenient purposes. And then let me just grab, so normally you would probably do your cleaning, your data cleaning in Power Query, as we all know, or if it's something even bigger, maybe you do it outside of Power Query in a other data warehouse, and then you bring it in, or you do your ETL on the cloud. For the purpose of this demonstration, in my definition, cheated. I prepped the data source before bringing it into Power BI. I know, really bad. But I did this again for the sake of having something easy for the demonstration, and also for that so that you can try it yourself and it's all ready to go for you and you don't have to worry about actually cleaning the data. So have the housing data prepped data set here on my Excel. The differences, so in the full one, it's going to have values such as date. It's going to have zip code, latitude, and longitude. These are non-additive values. They aren't things that you can make calculations on. It's more like a text than an actual number. So that's why those were one of the first things I did delete. And then to simplify it even further, I just picked 3 main ones. And for the bonus, actually at the end of the blog, there is a prepped bonus data set, which is basically just a bigger version. I just deleted less of the columns. Okay, perfect. So let's go into Power BI and go into let's do it from scratch. So we have our fresh Power BI desktop right here. We're going to get data. We're going to get data from an Excel workbook. So I'm going to go find this on my other side here. So I'm going to go to my housing data prepped. Cool. So there's different ways you can import. Just in case you guys want to know, import data from Excel, Excel workbook, get data, choose Excel workbook. Sometimes when you just open up Power BI, you can click get data, click Excel workbook. I'm going to click our first one here that's housing data. That's going to grab the table that I have already made instead of any empty values. I'm going to go straight to Power Query by going to transform data. So Power Query is where we do our transformations to the data before we go into the building our relationships and making our visualizations. So we have our beautiful housing data set here loaded into our Power BI model. In the transform ribbon up here, you will see at the end here, we have run R script and run Python script. We're going to go to run R script. So anything after the pound here is anything that you can write text. So it's not going to be in a calculation at all. It's not going to read as a calculation, which is why it does have the pound in front of it. But I'm just going to delete that right now. I'm going to put that formula that I do have in the blog, the script that you can copy paste from the blog into your R script here. So I'm just going to copy that first, and now I'm going to explain more of what this means. So what is this script doing? Model. So this model here, it's naming the function as model. This function, LM, bracket price, squiggly line, data set. This is actually the function for regression. So it's usually X, Y, and then data set, signifying why the X and Y's that you're going to use in your data set. So if you are going to use this on a different data set, the only thing you'll need to change in this R script is your price. So the price is representing for me my my Y, my predicted value. So if you were predicting, let's say, salary, like in my last blog, that would be what you would replace price with. Whatever you're predicting with is what you're going to replace price with. So basically, it's doing the regression model on this data set, this data set, based on the column of price. So it's telling the R script a command. It's saying this price is, or this column, I want you to model this as regression. I want to predict this value, and I'm going to name it model. DF, so DF is what we are naming the table that we want created, and we want a table created, so data frame, based on the coefficients of the model. So model is what we named our regression function. So we want to make a table based on this regression function. Third line is saying that we want the name of the column to be coefficients, and then we want all the row names to be the variables. So when I press OK here, continue. Oh, it just wants to be safe, which is good. I just put ignore privacy levels. It's probably from my company, just trying to be safe. So it's going to bring you this funky thing. So it's created a table for me, and it's named that table DF. To open up this table, I'm just going to press table. So we have our coefficients all right here. Coefficients are the power it gives to the price, and the variables is going to be the variables, the name of what that power is holding on to. So for the variable of bedrooms, the coefficient is negative 57,906. So that's how much of an influence it has on the price. So with this equation, like we can do the same thing that I was doing before, but take these numbers instead. So now I want to take y equals, so y is our price, 7, 4, it will be 7, 4, 6, 2.1. So this is going to be our y-intercept bit here. And then we have our bedrooms is our the negatives, so negative 57,906 times bedrooms. Ooh, bedrooms. My apologies for the writing. And then it would go on and so forth. So this is our B1, and then this is our X1, and the next one's going to be our B2 and our X2, and so on and so forth. So we have it for 3 things there. Awesome. We are so close. Let us close and apply this and go to our reporting canvas. We'll wait for it to load. So as I was saying before, we are going to now create what-if parameters. A what-if parameter allows you to create an interactive slicer with a variable to visualize and quantify another value in your report. So we're going to go to the modeling ribbon, and we're going to go to new parameter. This new parameter, I want it to be represent my bathrooms, and let's just put it maximum 15 bathrooms in a house, and I do want it to make sure it's check marked, so I add slicer to the page. And it added that slicer to the page for me. So this slicer allows me now to move up and down the numbers of bathrooms that I want for my price. And it has also actually created a measure technically for that parameter, and it also created a table, which is just a series of values for those bathrooms. So that is what it created for bathrooms. So now I'm going to super quick create the other two for bedrooms and square foot living. Let's do 15 again. Let's move that down so you can see it. New parameter. And then we have square foot living. And we can make this 100,000. And maybe let's do an increment of 100 so that it's not like 1, 1, 1, 1, 1. Amazing. So now we have our 3 what-if parameters. We can go up and down to choose values on these what-if parameters. And now we just need to calculate or make the prediction of the price. So in order to do that, I'm going to go into my housing data set here. I'm going to right click and click new measure. And we're going to make a measure that represents that calculation that I was writing out before. So the price equals our B-intercept equals the power of how powerful that bedrooms is times our what-if parameter. So whatever value we want that value to be. So for that, it's going to be, I'm going to copy paste just to make this a little bit more faster. Okay, so let's make this bigger so that everyone can see. Okay, so it has a red arrow right now because I believe I named it square foot living and square foot. That worked. Bathrooms value square. What I'll just do is perfect. Okay, let's make. So this is what I was writing before. Price is equal to that B-intercept minus. This is a minus and not a plus now, because if you remember, our bedroom's value, I believe, was negative. Then we have our plus our factor of how powerful it is times whatever bathroom value we want. And the same thing for our square foot living value. So we have our measure, we have our metric, our calculation. Now we just need a card visual. So to put the card visual, I just click the card in the visualizations pane. And I want the field for that card visual to be price. So I'm going to drag the price into the field visual. And voila. If I move any one of these, it is going to adjust the visual based on that number, based on how what the factor is for that number. Ooh, this one might be a little bit off. I might have mixed up bedrooms and bathrooms by accident, but the one in the blog demo is right. All right, so for this, there's also a bonus one as well. Let's go back to the over here. Okay, so try doing linear regression with one of these fun data sets yourself. I'm going to show you what the bonus one looks like now so that you have, like how the price Predictomatic looks, because it's pretty cool, like to have all of them. Let's see. So this is actually my blog. You can just look it up too with how to do multiple linear regression in Power BI, and the dashboard is clickable within the blog. Can I? Oh, I'm just gonna go to there and result bonus. Oh, that's not what I wanted. Just wanted. Okay, we will full screen it then. Oh. Okay, well, if you guys can possibly see this.
You might have to zoom in once you do the full screen.
Got
if
it,
you zoom
got
it
it,
again.
got it. Thank you.
Yeah.
Took me a second, but I got it. Perfect. So we have the bonus challenge also in the blog as well. So you can choose views in this one. You can choose how many floors you want. You can use how much you want square foot of the actual lot. So maybe you want an acreage. I also gave a hint to help you along on what that DAX formula will look like. In this blog as well, the dashboard has like a very simplified version of the steps. It is all written out as well if you prefer to read it. Be sure to click around. It is interactive. It will show you everything that I've just showed you for like what you have to put in, what is the formulas, what is the results, what the table should look like at the end, what you have to enter for each what if parameter, how to insert a card visual, and then how the result looks like, how it works. All of this fun stuff in the back here is just fun formatting that we made. It's a saved picture, and then we just changed the formatting of the titles and everything to white to make it pretty. So there's a lot you can do for user experience for this to make it a cool almost game, as you can see. And then I will go back to that original one here. Perfect. So please try this yourself and let me know how it goes on LinkedIn. Please connect with me on LinkedIn. There are some cool ones here. Car price prediction. There's one of startup companies. Marketing. There's a marketing data set. So it'll be like, I think it's something, it's a little bit older. So like how newspapers, emails, and word of mouth kind of compare to each other. Predicting end semester performance. That looked really interesting to me. So if anybody wants to do that and give me a shout out, that would be awesome. Stay tuned for more Power BI how-to guides and updates on new Power BI features. I will be working on more throughout the year. I am also going to be updating the simple linear regression blog to add a page where you can see how to do that last visual, as I didn't include that in the blog, and I've been getting a lot of questions around that. So I would love to show you how to do that in a blog page attached to that. If you have if you want to do some more research on multiple linear regression or look at any of the resources that I used for anything, they're going to be in the PBIX. They're also in the blog. And there's some in the chat for you as well. And also, I think, Stephen Zielk, Renata already mentioned him, but he also made a really cool blog on the creating a simple Naves Bayes predictive model in Power BI. So it's like another statistics model that you can do in Power BI. And he used a Titanic data set. So it's super cool. I would highly recommend you give that one a read. And yeah, thank you so much for listening to my presentation, for attending the Power Platform user group. I really hope that everyone learned something today and or maybe try doing the 4 assumptions do multiple linear regression for your organization, and let me know how it goes. I would love to know your statistical analysis and how you apply it to your organization. So thank you very much.